Hi, welcome to this video. This video is for Leetcode 57, insert intervals. It falls under a category of problems relating to intervals in general. The previous video we talked about inserting a new interval into a list of intervals or an array of intervals. So for this problem it says, given a set of non-overlapping intervals, insert a new interval into the intervals, merge if necessary. You may assume that the intervals were initially sorted according to their start times. So a couple of things related to this particular question prompt that makes this easier to solve. And so I think the thing that you really want to take note of is that the original set is non-overlapping and it was sorted according to the start times. That means you don't have to worry about sorting the initial one that's given, just have to figure out how to insert the new one. And they basically tell you what the two steps are. The first is to insert and the second is to merge. So let's take a look at the way to solve this. So first, you want to look at the input. We have the input directly from the Leetcode example, and you have 5 intervals given, which we list down here, right above the number line. And then we're given this new one that we want to insert, and we want to see what we do with that. So remember, the strategy is to insert, and then you want to merge. It might seem a little complex to insert an interval or an array into a current array that has a list of arrays, but there are ways to look at the problem to make it more simple to the mind. So let's take a look. The way you do that is, instead of thinking about where to insert this new interval for to just focus on the initial numbers in each one of the current intervals. So you have 1, 3, 6, 8, and 12. And when you insert that, you're probably going to get 1, 3, 4, 6, 8, and 12. But how do we do that? So the best way to do that, I think, is to really imagine the arrays instead of horizontally as we do here up at the top, but imagine them vertically. So you have 1, 2, 3, 5, 4, 8, 6, 7, 8, 10, 12, 16. I made them into different colors for a reason, because if you just imagine the top half, then you're just basically trying to insert a number into an array, which would be an easier question than the question that we were asked in the first place. So if you take a look, if you're given 1, 3, 6, 8, and 12, and they want you to insert 4 where it's supposed to go, well, basically, you loop through, you check 1. You say, well, is 4 lesser than 1? No. Well, then you check 3. Is 4 lesser than 3? No. Is 4 lesser than 6? Okay, well then, that's where it goes. Okay? And you end up with 1, 3, 4, 6, 8, and 12. So, once we take a look at inserting, if you have inserted correctly, you have what you have at the top here, where it's sorted according to the initial number of the arrays. We see that's correct. And now it's the merge step. The merge step is where you have to consider one item with its neighbor, or one interval with its neighbor. In the previous merge intervals video, we saw that it makes more sense to have a previous and a current, as opposed to current and next. It's just a mental trick that you should do for this particular type of problem, or sometimes when you want to compare one item to its neighbor. So you set the previous to the very first item and the inserted intervals, right? So it's going to be 1, 2, and then you set the current to the one right after that. So we're going to compare. What do we compare though? Well, we're comparing the previous tail, which is 2, with the current head, which is 3. And you see right here, there's no overlap between these two bars on the number line. So basically, we do nothing. We push forward previous and current, and we move on. So now you notice that we pushed everything forward, previous and current. So we're comparing 3.5 with 4.8. So what do we actually want to compare? Once again, we want to compare the previous tail at 5 with the current head, which is 4. Is the previous tail greater or equal to the current head? It is. So a merge step is necessary. How do we do that? Let's take a look. Well, you merge it by saying, okay, I'm going to keep the previous head, right? But I want to see which tail do I take. So you try to see, well, there's a 5 and there's an 8, and I want the maximum of that. So it's either here on the number line with a 5 or here on the number line with an 8. Obviously, we want to take the 8. So we'll see what happens if you merge that later on, what you get. Well, what you get is that you got rid of that 3.5 that was previously here, right? I'll put a dotted line here, and now you have this longer intervals here. And so this 3.5 and 4.8 turn to 3.8, and now the current is right here, 6.7, right? And so what do you want to compare? Once again, you want to compare the previous tail of 8 with the current head of 6. And of course, because it is greater or equal than, you want to merge. And after you merge, you want to see which one of the tails that you want to get. Now, if you look at the number line down here, you see that, you know, the 3.8 completely starts before 6.7, ends after 6.7. It basically wraps it completely. So you really don't have to do anything besides just keep the 3.8. That makes thinking about that step easier. So next step. So now that you have basically merged 3.5, 4.8, and 6.7 up here, and here represented in the numbers line, you want to take a look at previous, which is 3.8, versus current, which is 8.10. Again, what do we compare? Compare the previous tail to the current head. Now we see that they're actually equal to each other, so you're going to perform a merge. Now the merge step, you can imagine if instead of writing it out, you just think about this particular number line versus this particular number line. If you merge them, it'll end up starting from 3 and going all the way to 10. So take a look at the next slide. And that's your answer, because what you did was you took 3.5, different color, 3.5, 4.8, 6.7, 8.10, merged all that together into this one long interval, and then you have 3 left. And that's the final answer you're going to get for that particular example, which, let's take a look at the Leetcode question again. There's Leetcode 57, insert intervals. All right, thank you.